This video we're going to explore the concepts of the rate of change. So let's say I have a person here who's here, and he's got a ball and he wants to throw this ball in this direction. Now we know that it's going to move in a parabolic arc and end up over here somewhere, right? Now, what would I have to do if I wanted to know what the rate of change, so this is my y-axis and this is my x-axis, what the rate of change in my y-axis with respect to my x-axis was, right? Because what I do know is I know how this ball moves vertically with respect to time, so this is my dy by dt. I also know how it moves horizontally with respect to time, dx by dt, but I don't know this quantity directly. Well, what can I do? I can use my famous chain rule, because I know that dy by dx is going to be equal to dy by dt times dt by dx. And furthermore, that this quantity here, dt by dx, this is just 1 over dx by dt. So it's fairly simple for me using the chain rule to work out my unknown quantity. If that seems a bit abstract, don't worry about it, because what we're going to do right now is we're going to go into the example 3. And this tells us that there is a ladder 5 meters long leaning against a vertical wall. The bottom of the ladder is pushed along the ground towards the wall at a constant speed of 0.4 meters per second. How fast will the top of the ladder be moving at the instant when the bottom is 3 meters from the wall? So this is a diagram of what we've got. We've got a 5 meter long ladder, and it's being pushed in this direction at 0.4 meters per second. Now when x is equal to 3 meters, what is the upward speed of y? So let's try and translate this into maths talk, right? We want to find the upward speed. What does that mean? That means we want to find dy by dt. What do we know? This is 0.4 meters per second. What is this? This is actually our change in the x-axis with respect to time. And if you notice the direction it's going, the x value would actually be decreasing. So technically this is negative 0.4. Now, what do we need to do then? If we want to find dy by dt, we need to use the chain rule. This is going to equal dy by dx times dx by dt. So dx by dt, this one here, we've got, no worries. But how do we find dy by dx? Well, I need a relationship between y and x. And it just so turns out that I have one. This is a right angle triangle, right? With sides 5, x and y. So what can I say? I can say that y squared plus x squared is equal to 5 squared, or y is equal to the square root of 25 minus x squared. And this I can differentiate. This isn't too difficult. We've done things like this already. So dy by dx, so this is the same as the whole thing to the power of a half. So if I differentiate this, what do I get? Turns out I actually get negative x over the square root of 25 minus x squared. So I can just put this and my 0.4 into this formula. So what do I get? I get dy by dx, sorry, dy by dt, don't know why it does that every time, dy by dt is equal to dy by dx times dx by dt. So dy by dx was equal to negative x over the square root of 25 minus x squared. and this was negative 0.4 and was constant. So we're not just asked to find the general formula for dy by dt, we're asked to find it specifically, dy by dt, at x equals to 3 meters. So this is easy enough now. We just substitute in 3 every time we see an x, 25 minus 9, negative 0.4. And if you plug this into a calculator or do a little bit of arithmetic, you find that this is 0.3 meters per second.